This is question, but this needs explanation through drawing. I will explain this in the form of drawing by watching this video that I have given this. Okay, so let's watch it.
Yes. So first step, we are going to plot the vertex. So let me start with P right here, and then Q right here, and then R right here, and then S. Okay. Okay, after that, let's try out, which is we start from degree in P. Degree in P is 1. So you can start from S, you can start from R, you can start from P. You can start from either three of this to P, but I choose S, okay? Okay, alright, then degree out P. Also 1. Whether you want to go from P to Q, or P going to R, or P going to S with multiple H, you can choose either one. But me, I'm going to choose to Q because it is the easiest way. So P, Q. We go to degree in Q. Degree in Q is 3. So let's try from P to Q. Already has 1. And then maybe from R to Q. R to Q. Okay, already have 2. Maybe next 3. Another one, maybe I really don't recommend to cross first. Let's try with loop. So loop. Okay. Okay. Okay, then degree in R, 0. So there will be no one here going to R. Alright? And move on, degree out, R, 3. So R to Q already done 1. Another 2. Another 2. That is right. Maybe R from S. Sorry, maybe S from R. So there are 2 already. Another one. For degree out, R. So you want cross? No, I think crossing part would be the best way for the last choice. This prevent ourselves from crossing part K because it is going to be a little bit danger for teachers to give our marks in exam. Okay, so another one. Where? Maybe we can have the multiple answers. So just for my imperfect lines right there. And then we move on to degree in S, which is 3. Oh, there are already 3 right here. 1, 2, another one. Oh, maybe we could add from Q. This is the crossing part, as I said just now. Crossing part is the best way for the last choice, okay? So, there are already 3 degree in for S. Then, degree out for S. Oh, only 1, so S to P already 1. Okay, after that we're done.
Okay, I hope you understand how to draw based on the question given. Okay, so we move on to the next slide. Okay, subgraph. What is subgraph? So based on the slide, subgraph is a part of a graph or the whole graph be drawn without changing the original, which answer some questions. Okay, the question asks, determine whether diagram 1, diagram 2, and diagram 3 are the subgraphs of graph P. So this is the example of question that you are going to face with an exam or exercise textbook. Okay, so this is the graph and this is the diagram. So the graph is the original graph, of course, but the diagram is the picture that we drawn from the graph P. Okay, for example, is diagram 1 subgraph of graph P? Yes. As we look at here, PS, PS, E5, E5. Anything that's same with the graph P, anything would be subgraph of P. So diagram 1, yes, it is a subgraph of P. So how to answer? You can look at here, yes, because the vertex pair for edge E5 is the same. You can see here E5 and E5 here is the same. But we look at diagram 2. Diagram 2, okay, write this as P, E1, Q, E5, E2, loop right here. Okay, let us look at the diagram and the graph. So S, E5, okay, P, okay, E1, okay. But loop E2 right here should be at P. Sorry. Oh my god, sorry. Loop right here should be at Q, not at P, because we have to base on graph P, right? So the loop right here should be right Q, not at P. So that is why diagram 2 is not a subgraph of graph P. For example here, no, because the position of loop E2 is not on vertex Q. Okay, based on diagram 3, you can see here S. Okay, S, E3, P, Q, E2. Okay, S, E3, no, E5. So right here we know what's wrong with the diagram. So E5 should be, E3 should be E5. And then P, okay, P, same. Okay, it's okay. Then we go to Q, E2, E2, same. But if one at here is wrong, so the answer should be no. Diagram 3 is not a subgraph of graph P. As we look at here, no, because the edge connecting vertex P and vertex S is not E3. So this is the explanation why we said no. Okay? Alright. Based on the next slide. Okay, tree of a graph. What is a tree of a graph? Okay, it is a subgraph of graph with the following properties. Let's look at the properties. As we can see here, the question asks, determine whether each of the following graph is a tree. Justify your answer. So, graph A. Why do the answer should be not a tree? Because when we look at here, the vertices. 6 vertices. Okay, 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5, 6. 6 vertices. And then 7 edges. If you want to know whether it is a tree graph, the edges should not be more than the vertices. If the value of edges is the same as the value of vertices, that still we call a tree graph. But if the value of edges is more than the value of vertices, it should not be called as a tree graph. So that's why right here, based on graph A, there are 6 vertices. 1, 2, 3, 4, 5, 6 vertices, but 7 edges. 1, 2, 3, 4, 5, 6, 7 right here. So the value of edges is more than the value of vertices. So that's why we cannot call it or label it as a tree graph. However, in graph B, it is a tree. Why? We look at here. There are 6 vertices. 1, 2, 3, 4, 5, 6. But 5 edges, which is the number of edges is not more or exceed than the vertices, than the value of vertices. So that's why it is called a tree graph. Okay? That's all from me. Thank you.